In our last video, we saw how to find the duration of a bond, conceptually what it is, that is the fulcrum on the seesaw. And we saw mathematically how to calculate the duration of the bond. Let's go back to see our seesaw again, because I think that is helpful here. So let me bring up a whiteboard and show that to you again. So here we've got the same bond we had a second ago. Here's in our last video. Here's time 0, time 1, time 2, time 3, and time 4. There's $4, $4, $4, and $104. And we saw that where we place the fulcrum in order for it to balance was at the time of 3. I think it was what, 3.77. 3.77. But since these are semi-annual periods, okay, 3.77 semi-annual periods is in fact where this would balance out, but that's not going to be the duration of the bond. What we want for the duration of the bond is 3.77 divided by 2, because we want it to conceptually be where would we be in years. And in years, this is 0.5, this is 1, this is 1.5, and this is 2. So where this fulcrum would be here in terms of years is going to actually be at 1.885. So that is the duration of our bond. It's 1.885 is what we find there. Now, how do we go about finding this in Excel? Well, good news for you, and that is that there is a function for duration in Excel. It's already there in Excel that we can use. So let's excuse me. Let's bring up Excel here and take a look at that. This is going to be a spreadsheet on duration, modified duration, and convexity examples. Here we've got the bond we've just been looking at here. Here is its face value is $100 there, and then has a coupon rate of 8%. It matures in 2 years. The yield on the bond is 10%. And as I told you before, the price is going to be $96.45, calculated from that information, the face value, the coupon rate, and its maturity, and the yield on the bond. There's our formula right there to find the price of the bond. I put a little negative sign in front of here just so we didn't have a negative price there, so that'd be a positive number. Now, let's suppose that this bond, you buy it on February 10th of 2020. That is the settlement date, okay? And that it matures on February 10th of 2022, exactly 2 years later there, okay? How do you find the duration? There's it right there. The duration of the bond, okay, that's a function in Excel, is going to be found by, first of all, we have to put in the settlement, which is in cell B7. That's got to be a date. And remember, Excel it's got to be in the right format for Excel, so that Excel knows that that is a date that it can convert to a number. In fact, it does convert that to a number. And then we've got the maturity. Okay, here's the maturity on that date. That's in cell as a date. That's going to be in cell B8. The coupon rate is going to be in cell B3. The coupon rate of 8%. The yield on the bond is going to be in cell B5. That's the bond equivalent yield, or yield to maturity, same thing for us. Frequency is how frequently does it make its coupon payments, twice per year. And the basis, I just left it blank. We could put the basis in as a 1, and it really isn't going to change anything there. Maybe like the 4th decimal, or something like that. But it's still 1.885. Okay, no matter what we put in as basis. So there's the duration. 1.885 is going to be the duration of the bond. Now, that number will be better understood, what it means when we calculate a bond's modified duration. The modified duration is simply going to be the duration of the bond divided by 1 plus R. So for bonds that make semi-annual coupon payments, that means R is going to be the semi-annual yield. If you have a bond, and we won't have it in this class, but if you have a bond that makes annual coupon payments, R is going to be the annual yield. Okay, but for us, it'll be semi-annual. So 1.885 divided by 1 plus the semi-annual yield gives us the modified duration. Now, remember the semi-annual yield in this bond, since the yield to maturity is 10%, the semi-annual yield is 5%. So let's go here and let's say this is going to be equal to the duration of the bond, okay, divided by 1.05, okay, which is 1 plus the semi-annual yield. And if I get that, I see it's 1.7945, et cetera. Well, that is the modified duration of the bond, okay? And that's perfectly acceptable to calculate it that way. But an easier way is, guess what? There's a modified duration function in Excel, M duration. And what does it ask for? It asks for the exact same arguments. It asks for the exact same information in the parentheses that duration does. Look, here's what duration wants: B7, B8, B3, B5, 2, and 1. And here is what modified duration wants: B7, B8, B3, B5, 2. And I didn't have the basis in there already. We'll put it in now. And 1, and there is the modified duration of the bond there. So the modified duration, what Excel is doing, it is calculating the duration and then it's dividing by 1 plus the semi-annual yield to give us the modified duration. So we now know how to calculate duration of a bond, and we need to calculate we know how to calculate modified duration. I think it's about time we actually found out what these numbers really tell us. We know they have something to do with interest rate risk, but let's be a little bit more specific here. So let's go back to the whiteboard, and on the whiteboard, we are going to draw the relationship between a bond's yield and its price, the relationship between a bond's yield and its price. And let me clear what we've already got up there. I think that'll make life a little bit easier for us here. So here is going to be the price of a bond on the y-axis, and here is going to be the yield to maturity. Bond equivalent yield means the same thing for us on the x-axis. Now we know as interest rates, yield goes up, the price of a bond goes down, but it's not on a linear relationship. It is a convex relationship, meaning it's going to look something, and I don't draw very well, but I'll do as best as I can, something like that, okay? That, hey, as interest rates go up, the price of the bond comes down, but not according to a straight line. It is convex. And we kind of know that because we saw earlier that when interest rates are very high, the bond has less interest rate risk. In other words, the price won't change that much if interest rates go up and down by 1%. But if interest rates are very low, then the price does change by a lot more when interest rates change by 1%. So you can kind of see that on here. So this line shouldn't be straight up here, but I've tried to draw a convex curve as best as I could. Well, let's suppose that right now, this is where our bond is. This is the price of the bond right here, and this is its yield. That's where interest rates are. Well, if we draw a line that is tangent to this point, meaning it just touches that point right there, goes down there, it has the same slope as the curve right at that point, okay? The slope of that tangent line is going to be the modified duration of the bond. With one little exception. We can see that this line has a negative slope. We don't typically put a negative sign in front of modified duration. We just leave it as it is. So the bond we're looking at had a modified duration of 1.7955. So the slope of that bond would be 1.7955. It is what we call a first order approximation of the price sensitivity of this bond due to a change in interest rates. Meaning at this point right there, if interest rates go up just a little bit, okay, then the price of the bond is going to come down by the amount, by an amount equal to the slope of that tangent line. If interest rates go down by just a little bit, then the price of the bond will go up by an amount equal to approximately the slope of that line. Now, because the actual change between the price of the bond, or the actual change of the price of the bond goes along this curved convex line, the tangent line is an approximation. Now, it's a very good approximation for very small changes in interest rates, but it's not as good of an approximation when there are larger changes. For example, if interest rates will move from here to there, well, heck, that's going to be a pretty good approximation. But if interest rates move all the way up, say, to here, then our straight line is going to go something like this, and there's the curved line, and there's going to be a big difference between the two. So modified duration is going to tell us approximately what is the percentage change in the price of the bond when there is a 1% change in interest rates. So let's go back to our Excel spreadsheet so we can see this a little bit better. All right, and we see here that bond number 1 again, that if interest rates, we've got here a change of 1%, okay? That is going to affect column E. So columns A and D are basically telling us the same thing. The face value of the bond, here's the coupon rate, here's how long till it matures, but we're over here, we've got the current our yield on the bond, okay, where it starts at is at 10%. Here we're seeing what the yield on the bond is when interest rates go up by this amount and sell H1. So if interest rates go up by 1%, the new interest rate is 11%. Before interest rates went up, this was the price of the bond. Now that interest rates have gone up, this is the price of the bond. Interest rates go up, the price of the bond goes down. It goes down from 96.45 to 94.74. So what we're doing here is we're saying, what is the percentage change in the price of the bond? Well, the bond went down by 1.7747048% there. Now, here is the duration of the bond. Here's the modified duration. Now, remember what modified duration is telling us. It's an approximation of what is the percentage change in the price of the bond for a 1% change in interest rates. Well, here we have a 1% change in interest rates. Interest rates are going up by 1%. So modified duration is predicting that the price of the bond will go down by 1.795457%. So that's right here in this cell. This cell is telling us how much modified duration predicts. And then this cell is telling us how much modified duration is off by. And you can see it's off by a little bit, but not by a whole lot there. Where modified duration is going to be really accurate is for very small changes in interest rates. Now, actually, a 1% change in interest rates is really a big change. I mean, that's a humongous change. Let's think about a 1 basis point change, okay? Make the change 0.01%. Now, for a 1 basis point change, modified duration is predicting the price of the bond will go down by 0.0179546%. It actually went down by 0.0179525%. So the difference, modified duration, is off by 0.000021%, not by much. Modified duration did a pretty good job of predicting the change in the price. By the way, it works the same way if interest rates go down. If interest rates go down by 1%, we'll put a minus sign in front of here, then modified duration is predicting that the price of the bond will go up by this amount. Here's the amount it actually went up by, and modified duration, again, was off, but not by too much there. Now, if there is a bigger change in price, let's say a really big change, like 3% here, put a 3% there. Now, modified duration is predicting that the price will go up by 5.38%. But in fact, it only goes up, modified duration is predicting the price will go down by 5.38%. And in fact, it only went down by 5.20%. This is maybe not as close of as good of an approximation as we would like it to be. So modified duration is not going to be as accurate as we would like for really big changes in the in interest rates. If we go back to our whiteboard, we'll see again the direction that modified duration is off by. okay, that we see here on the whiteboard, that if interest rates go up, modified duration is going to predict that the price of the bond goes down by more than it actually does. Okay, and we saw that with the Excel spreadsheet. If you want to go back and take a look at it again, and you'll notice that. If interest rates go down in this direction, then modified duration is going to predict that the price of the bond will go up by less than it actually does. So if interest rates go down, the true rise in the price of the bond will be greater than what is predicted by modified duration. If interest rates go up, the true drop in price of the bond will be less than what is predicted by modified duration. So modified duration does a really good job when interest rates are changing just a little bit, just a few basis points of predicting the change of price. It does not do such a good job if interest rates are changing, say, by 2, 3, 4%, something like that. Most people feel most of the time comfortable with modified duration. Now, something we're really not going to get into, okay, but I just want to make you aware of, is if you want to be more accurate than modified duration for these greater changes, you can add something to modified duration, and that is called the convexity measure of a bond. If you add convexity to modified duration, you get a better approximation for changes in the for changes in interest rates. Basically, what you're doing with the convexity measure, if you this straight line there, okay, is the first derivative of the function. Okay, a tangent line is the first derivative of the function at that point. Convexity is going to be the second derivative. When you add the second derivative to the first derivative, you get a better approximation of the function. That's something dealing with Taylor series expansion, which some of you may have had in some of your advanced math classes, which you do not need to understand that for this. But understand that what convexity does is it gives you a better approximation. So understand that that is possible. However, we're just going to deal with duration and modified duration. For one thing, Excel doesn't have a function for convexity there. So duration is going to be found with the function, okay? And it is, and remember, duration is going to be where on this timeline you place the fulcrum when you've got, you know, the cash flows up there. You take the duration, okay, divided by 1 plus R. That's going to be where R is the semi-annual yield. That's going to give us the modified duration. There's functions in Excel for each one of them. Modified duration is going to be the slope of the tangent line to this curve, which shows the relationship between the price of a bond and the yield of a bond. So modified duration is an approximation of the change in the percentage change in the price for a 1% change in the yield.